All right, example 1 here. If a fair coin is tossed, what is the theoretical probability of the coin landing on tails? So again, even if this hadn't told me it was theoretical, I know that it's theoretical because there's no data provided to me about an experiment. So I have nothing else to go off of based on other than what I know about coins. So the probability of that coin landing on tails would be 1 out of 2, because I know that there are 2 sides of a coin and one of them is a tails. Example 2. In an experiment, so this is where we start talking about an experiment, a coin was tossed 50 times. The results are displayed in this table. What is the experimental probability of the coin landing on tails? So here, our total is no longer 2 because our total, our bottom, our denominator is the number of trials. How many times did we flip this coin? And that would be that 50. So 50 is my denominator. And how many times did they land on tails? Well, my data and my table tells me 23. So 23 out of 50. Part 3 or example 3, and on your homework and stuff, these are going to be like a part A, B, C. How does the theoretical probability compare to the experimental from the previous 2 questions? So you can approach this 2 different ways when you're doing your homework. You could either 1, write a sentence using words, or B, use an inequality with symbols and numbers. Whichever one you prefer. So how do they compare? How do those 2 numbers compare? Well, if I look at 1/2 compared to 23/50ths, I know 1/2 is the same as 25/50ths, and I know that 25/50ths is bigger than 23. So 25/50ths, or 1/2, is, I'm holding up my hands to not put the wrong symbol, greater than that. So theoretical is greater than experimental. Or you could write that out as a sentence. The theoretical probability, I'm going to abbreviate probability, is greater than the experimental.